This is an introduction to the Chapter 6 problems, practices A through D, and it's also going to be a walk through the concept of the impulse equation. So I want to make sure that you understand what we're doing here, and the goal of this is to give you pointers as you work on the sample problems, and I'll also give you some equations that you should consider. That way you don't get frustrated and you don't get stuck. So the idea of Chapter 6 starts out with momentum, but then it quickly changes to the idea of what is called impulse. So let's look at that here. If we have the momentum equation, we have P equals m times v. But more importantly, we have P equals m delta v, because most everything we are going to do in this unit will involve a change in velocity because there's going to be a collision, for example. But now there's this other concept, and that is if you have a change in velocity, well, it's important to know how long that change in velocity takes place, because that has an impact on the force. So we have this equation here called the impulse momentum theory. Okay? So this concept here is the connection between impulse and force. Okay? So impulse momentum theory. Or theorem. Okay? And the idea is that it tells us that time now is a factor in a force, and so the amount of time it takes a force to act also can affect its change in velocity and so on. So it's all interrelated here. Okay? We're used to situations that have just one variable for a name, but this is impulse. Impulse is Ft, right? F alone is force, T is time, but here when you combine them they call it impulse, and so there is really there's no other variable for that. This is momentum, letter P, but we don't see that in physics, that the impulse would have a separate variable all of its own. Let's take this apart here. Ft equals m delta v. Okay? Because it's the same mass, and because delta always means final minus initial, we now have a situation here where we have mvf minus mv initial. You're going to see that that proves to be very useful for collision equations, because they're going to say something strikes something else and then it slows down, or some different velocity after the equation. So the impulse equation here can also look like this. Okay? So get comfortable rearranging this equation, and technically we should put the change in time. And the reason we do that is because t without the delta simply means a point in time, but here we want to indicate that it's a change in the time. All right, so what do we do now? I want to show you some of the concepts related to the problems that you're going to do. So I think we should just look directly at the practice problems here first. So this is on a PDF on Google Classroom, and these are your simple momentum problems. So these won't cause you any problem. These are going to be your basic P equals mv. The only thing I would point out with these is that you need to make sure that you indicate direction. If we look at the problem above, you'll see that they end up with this direction east, for example. And so just make sure that when you do this that you include a direction, because, like they say here, momentum is a vector quantity. Okay? Now let's look at this situation a little more closely. Okay? This force and impulse stuff, this is going to be a little more complicated, and this is going to take a little while. So I want to show you, just to make sure that you understand how we go through that. There's a couple equations that you might miss because we haven't used them in a while. Okay? So when we're looking at problem B, right? The practice problem's B. Okay? Make sure that you, of course, show direction. So when you're finished, you say to the right, to the left, and so on. And even if it's not for practice problem B, generally they will say that west is the negative direction, right, and east is positive, and that's simply because your number line here, okay? It doesn't have to be the case, but just be ready for that normally is a situation. We don't generally deal with the vertical plane, so we don't have to talk about north and south, but just be aware of that situation there also. Okay? The other thing then is be ready to isolate for V2 final, for example, any other number of expressions. Just be able to isolate variables first before you substitute. Otherwise, you'll find that section B isn't too bad, but it's going to take a while. All right? Now let's look at practice problems C. Okay? This one gets a little bit more involved for a reason. One is they ask you to go to a previous problem. And I'm not sure if the author was just being lazy, but they want you to go back to a sample problem on a previous sample, okay, a previous page. Notice here, though, that it says 20 meters per second to the west. Change that to a negative velocity. They didn't do that, and they should have done that to help you out. Otherwise, solving for time, that shouldn't be a big deal, okay? But when you do part B, right, the constant acceleration will actually be in the negative direction. So just if you get a negative sign or if you need to make some indication, you can always write a note to show that you understand what the problem is about. Okay? And then the same thing with number 3 is the author just keeps going back to this sample problem, and I think it's because they were a little bit lazy in setting up their own work. Okay? But there's also something else about problem practice C. One of the equations that they're going to give you is something we haven't seen in a while. Okay? And so they're going to ask you about the distance traveled. And so this one we haven't seen for a while. So use that in your collection of problems, okay, as we go through this. Use that in your solutions, and pretty much that's the only other equation that you will need for that section. Okay? Now for part D. Part D is more of a classic momentum type problem. Okay? And by that I mean it's going to be M1 V1, M2 V2, and so on, M1 V1 prime. So you won't find that to be too challenging, but again, it's going to be a little bit tedious, and it's just going to take you a while. But make sure that you show all of your units. Make sure that you are arranging for the variable first, and I'll show you that example here just to make sure we have it. M1 V1 plus M2 V2. These are going to be elastic collisions. That situation there says that we have an elastic collision, and I know it's elastic because these two masses do not stick together. And if you need to solve for V2 prime, you keep M1 V1, M2 V2 together. You subtract that expression, and then you can leave M2 V2 here. And then finally, we're going to save you a little bit of time. You would simply divide by M2, and that would give you your V2 prime. So that's just a warm-up to the idea of what you're going to do for practices A through D.